In this question, they are asking us to find the number of terms in the expansion of a plus b plus c raised to 20. Alright, so we have with us a plus b plus c raised to 20. If it was, is it a binomial? No, it's not. So if it was a binomial, a plus b raised to 20, for example, I would have said the expansion would have 21 terms. But this is not exactly a binomial, it's a trinomial. There are 3 terms here, a, b and c. So in such cases, what would you do? So you have to recollect that if you have any x1 plus x2 plus x3 all the way up till xr, alright, raised to n. If you expand that, it will have n plus r minus 1, cr minus 1 number of terms. Okay, so in any x1 plus x2 all the way up till xr raised to n, the number of terms will be n plus r minus 1, cr minus 1. Alright, so let's use that here. So here, what's the value of n? You can see n is 20, it's the power. Alright, r refers to the number of different types of terms, a, b and c, which means r is 3 here. Alright, so what will our final answer be? N 20 plus r 3 minus 1 c r minus 1, which is 3 minus 1. Then you get 20 plus 3 minus 1 is 22 c2. 22 c2 will be your final answer. But what's the value of 22 c2? This will be 22 into 21 divided by 2. So you get 11 into 21, which is 210 plus 21. 21 into 10 plus 1. Okay, so 210 plus 21 is nothing but 231. Got that? Alright, so this leads us to option A, 231. So remember what we did. If you have r terms, okay, and it's raised to some power n, okay, r terms are there and it's raised to the power n, the number of terms in the expansion will be n plus r minus 1, c r minus 1. Alright, got that? Alright, in this question, they are asking us to find the degree of the polynomial in this given expression. Alright, so let's begin. We have our expression given to us, root of 2x square plus 1 plus root of 2x square minus 1 raised to 6 plus 2 by root of 2x square plus 1 plus root of 2x square plus 2x square minus 1 raised to 6. So the second part should look pretty interesting to you right now. Okay, so what I do is I take 2 by whatever is inside the bracket. Okay, 2 by root 2x square plus 1 plus root 2x square minus 1. I'll multiply this by the conjugate, 2x square plus 1 root of minus root of 2x square minus 1. Okay, so 2x square plus 1 minus root 2x square minus 1. In the numerator, you can see a plus b, a minus b there. Alright, together they'll become a square minus b square. Okay, so a plus b into a minus b is a square minus b square. In our case, that's 2x square plus 1. The root sign just goes off. Alright, minus 2x square minus 1. Alright, so this becomes 2 into root of 2x square plus 1 minus root of 2x square minus 1 divided by, what is this? 2x square and 2x square cancel out. This minus 1 becomes plus 1 when you remove the bracket. This and this cancels out. There's a plus 1 and plus 1, which become plus 2. And this cancels out with the numerator. Alright, so what does our question now become? Our question is nothing but root of 2x square plus 1 plus root of 2x square minus 1 whole raised to 6 plus the second term becomes root of 2x square plus 1 minus root of 2x square minus 1 the whole raised to 6. Okay, this is the same thing what we are getting. And here, what do you see here in this form? You should be able to identify an a plus b raised to 6 plus a minus b raised to 6. Alright, so a plus b power 6 plus a minus b power 6. What happens when you add these terms up? The terms with the odd subscripts vanish. Basically 6C1, 6C3, 6C5. Those terms vanish. What I'm left with is 6C0 term, 6C2 term, 6C4 and 6C6 terms. Okay, these are the terms I'm left with into 2. Alright. So what is 6C2? That's 15. 6C4 is also 15. And 6C0, 6C6 is 1. So that's why you get a power 6 and b power 6 here. Alright. Let's begin. So we can write this as 2 into a power 6. What is a? Root of 2x square plus 1. Root 2x square plus 1 raised to 6. Okay, this is a power 6. Alright, I can write this as 2x square plus 1 the whole cube. Alright, I just remove the root sign. Raised to 1 by 2. Which means 6 into 1 by 2. That's why the power here is 3. Alright, so here you can see that this becomes the expansion. Okay, the expansion is here. 2 into 2x square plus 1 cube plus 15 into 2x square plus 1 square into 2x square minus 1 and so on. Alright. So here what is the question they were asking? They were asking us simply to find the degree of this polynomial. Okay. To find the degree, let's not expand this any further. Look at this. So you see an x square here and you see that this is raised to 3. Okay. So the largest power of x square inside this is x square raised to 3, which is x power 6. Alright. Here in this term, largest power of x will be x power 4. You see the x square and you raise this to 2. Similarly here, there will be an x square. So that becomes x power 6. Next, over here, what is the largest term? In the first part, I have x square here. In the second part, I have x power 4 here. Alright, so that together is again x power 6. Similarly here, the last term, x square is there. You raise it to the power 3. You get x power 6 again. Alright, so x power 6 clearly is the largest power of x in the expansion of this given expression. Alright, so here x power 6 will be the largest power. So hence the degree will also be 6 here, which is option A. Got that? Alright, this question is asking us if A equal to 3 raised to 1 by 223 plus 1 and Fn equal to sigma minus 1 power r minus 1 NCR minus 1 A power n minus r, where r moves from 1 to n. Okay, for all n greater than 3, greater than or equal to 3, we have to find the value of f of 2007 plus f of 2008. First, we'll have to make this look simpler. Okay, this f of n value is here. It should look simpler than what it is. Okay, for that, we have a equal to 3 raised to 1 by 223 plus 1. Alright, so here, how do I deal with this? I can write this as sigma r equal to 1 to n NCR minus 1 into minus 1 power r minus 1 into a power n minus r. Okay, this form almost looks familiar, doesn't it? Right. So if I have NCR x power n minus r into y power r sigma r equal to 0 to n, this is nothing but the expansion of x plus y raised to n. Alright, so we'll be using that here. Okay, so here I have NCR minus 1. So r minus 1 is there in place of r here. Okay, so minus 1 power r minus 1. So the first term looks like minus 1. The second term here is a power n minus r. Okay, now what do I need there to convert it into this form? To convert it into this form, I need to write it as a power n minus r minus 1. You take this n, you take this r minus 1, you subtract both. Alright, so you get a raised to n minus r plus 1. Okay, so to bring n minus r plus 1, I have to multiply by a and divide by a. Alright, so this becomes sigma r equal to 1 to n NCR minus 1 minus 1 power r minus 1 into a power n minus r minus 1. Alright, this whole thing will be multiplied by 1 by a outside. Okay, so this is nothing but the expansion of minus 1 x plus y raised to n, right? So first, let's just expand this. Put this 1 by a outside. 1 by a outside. And let's expand this. Put values of r between 1 and n. What happens here? when I put values of r between 1 and n, I can see that this becomes 1 by a into nc0 a power n, binomial theorem. That's how we are expanding it. Minus nc1 a power n minus 1 and so on till ncn minus 1 a power 1. Alright, that is how I'll expand this. So, in this expansion, I want you to note that there's one term missing. If that term was there, then I could have written this as minus 1 plus a raised to n. Alright, so for that, what is the term that's missing? NC0 is there, NC1 is there, NCN term is missing. Okay, so I'll put that NCN term there. So that'll be plus minus 1 power n NCN. And you know already that NCN is 1. Okay, so this is the term I add into it. So I have to subtract that same term here as well. Minus 1 power n will be here and then I'll close the bracket. So here, all these terms till the second last term here in this series. Okay, the second last term here, till the second last term here, we have completed the series. Okay, so this becomes nothing but minus 1 plus a raised to n. Alright, so now what do I have here? I have minus 1 plus a raised to n into 1 by a as my f of n. Okay, but there's a minus 1 here. Don't forget, minus 1 raised to n. Okay, so there's a minus of minus 1 raised to n. Alright, let me correct myself there. It's minus 1 raised to n here. Now, how can I write this? This, I'll put the value of a here. Alright, a is 1 by 3 power 1 by 223 plus 1. Okay, this is 1 by a into, so a minus 1 raised to n. That's the first term. So a minus 1 means this 1 goes off in a. Okay, so here it becomes 3 power 1 by 223 alone raised to n minus minus 1 raised to n. This is the value of f of n I get. Alright, it will be 3 power 1 by 223 raised to n minus minus 1 raised to n divided by 3 power 1 by 223 plus 1. This is what we have till now. Alright, so let's continue. We have f of n like this and we are supposed to find f of 2007 plus f of 2008. Simply replace n with 2007, add it to the value you get from replacing n with 2008. Then sum both the values, you get your final answer. Let's do this quickly now. What do we get? F of 2007 becomes n of 2007 by 223 minus 1 raised to 2007 is minus 1 itself. So minus of minus 1 becomes plus 1 divided by 3 power 1, 2, 2, 3 plus 1 plus f of 2008. Denominator remains the same here, okay? 3 power 1, 2, 2, 3 plus 1. The numerator 3 power 2008 by 223 minus 1 raised to 2008. That is plus 1. So minus plus 1, which is minus 1 now. Okay. So this is what I get. So here I can notice that I can take a common denominator. Of course, that's the first thing you'll notice. 3 power 1, 2, 2, 3 plus 1, which means I can simply add these terms. Alright, so here plus 1 and minus 1 cancels out as well. So in all of this, I can take some 3 power something common. Okay, so I'll take 3 power 2007 divided by 2023 as the first term, which is common to both. Alright, so now first term becomes 1. The other term 3 power 2008 divided by 223 can be written as 3 power 1 by 223. Look, this 2008 divided by 223. Just look at this part. I wrote that as 2007 divided by 223 plus 1 by 223. That's all I did. That's how I took 3 power 2007 by 223 common. Now, 2007 by 223. What is 223 into 9? 223 into 9 is 223 into 9 is 2007. Alright. So here we can apply this. This becomes 3 power 9 into 1 plus 3 power 1 by 23. 3 power 1 by 223 plus 1. Okay. So I have here 3 power 2007 by 223, which is 9, into 1 by 1. Right. So here I have my final answer as 3 power 9 here. Okay, note that. So now this leads me to option B, 3 power 9. Got that? Alright, in this question we are looking for the coefficient of x power 18 in this given product. Alright, so let's begin our question. So we have with us 1 plus x into 1 minus x power 10 into 1 plus x square raised to 9. Alright, so here I can modify that a bit. I can write this as 1 plus x. I see this raised to 10 and this raised to 9. Okay, so I'll club the raised to 9 terms together. Basically, I'll take 1 minus x outside the 1 minus x raised to 10, and the remaining 1 minus x power 9 will be written inside this 1 minus x power 9 into 1 plus x square power 9. Okay, so then what does this become? This can be written as 1 minus x square, 1 plus x into 1 minus x. Then whatever is inside here can be written as 1 minus x into 1 plus x square, the whole raised to 9. Okay, this can further be written as 1 minus x square into, what is 1 minus x into 1 plus x square? That's nothing but 1 minus x cube. Okay, and this is raised to the power 9 here. Alright, so our general term in any expansion, 1 plus x raised to n, okay, will be tr plus 1. The general term will be ncr into x power r. Okay, so here we are looking for the coefficient of x power 18 here, remember. Alright, so x power 18, where do we get that? So for that, so this 1 minus x cube raised to 9 in this sigma form can be written as 1 minus x square into sigma NCR, which is 9 CR, where R goes from 0 to 9. Alright, x power R. So instead of x here, it's minus x cube. So this was a general term for any 1 plus x raised to n. Okay, this is 1 minus x cube raised to 9. So n is 9, that is fine. But then instead of x, you put minus x cube here. Okay, raised to R. Alright, this will be another way of representing this same expansion. Okay, so I'm looking for the coefficient of x power 18 here. Alright, so what do I do here? So first, I look at the coefficient of x power 18. I multiply with this 1 which is lying outside. Then I see this minus x square, right? So then I subtract from it the coefficient of x power 16. Okay, so in this expansion, 1 minus x cube raised to 9. I'm finding the coefficient of x power 18. From that, I'll subtract the coefficient of x power 16, because this x square will multiply with the x power 16 term to become x power 18. Alright, so x power 18 coefficient will be what? What will that be? For that, you put r equal to 6. Okay. Now, coefficient of 16, I see that each term will have the x term like this, x raised to 3r. So, since r is an integer between 0 and 9, x power 3r, the power of x will have to be a multiple of 3. Now 16, x power 16. 16 is not a multiple of 3, hence the coefficient of x power 16 becomes 0. Alright, it won't be there inside this, inside 1 minus x cube raised to 9. Okay, so I'm just looking for the coefficient of x power 18 here. I'm simply going to put r equal to 6. Okay, so when I put r equal to 6, when I put that, I get this term as 1, this one which is outside, into, what is that term here? 9c6 into minus x cube raised to 6. Alright, so the minus goes off here, as you can see. Okay, minus x cube raised to 6, minus 1 raised to 6 is 1 itself. Alright, so that goes off, and x power 18 arises along with 9c6 on this side. Now we simply need to find the value of 9c6. How do you find 9c6? So here 9c6 is 987 divided by 3, 2, 1. So 3 and 9 cancel out to give 3. 2 and 8 cancel out to give 4. I get 3 into 4, which is 12. 12 into 7. What is 12 into 7? That's nothing but 84. Alright, so the coefficient of x power 18 here will be 84. Let's look at our options. 84 here is option A. Got that? Alright, in this question, the coefficient of x square and x cube is equal to 0. We have to find the ordered pair A comma B. Alright, so in this expression, 1 plus ax plus bx square into 1 minus 3x power 15. We have that the coefficient of x square and x cube will be 0. Alright, so here 1 plus ax plus bx square is there, 1 minus 3x power 15 is there. We know the second part, we can expand it using binomial theorem. Alright, so when we expand the second term, what will the general term be? For each part, general term will be tr plus 1 equal to ncr x power r. In this case, this is for any 1 plus x power n. But we have 1 minus 3x power 15. So you replace n with 15 and x becomes minus 3x. This is what you replace. Alright. Now, here, let's write the first few terms actually for ease of calculation. 1 plus ax plus bx square is there. The second part is 1 minus 3x power 15. Let's expand that. First term will be 15c0. 15c0 is 1. Next term is 15c0 into minus 3x. Okay, so the first term was 15c0 itself. The second term is 15c1 into minus 3x power 1 plus 15c2 into minus 3x power 2 plus 15c3 into minus 3x whole cube and so on. I am writing only till x cube term. Why am I doing that? Because I'm looking for the coefficient of x square and x cube. So I won't need to go anything beyond that. Alright, there's no 1 by x anywhere. Okay, so this here we'll be first looking for the coefficient of x square. Okay, for the coefficient of x square, what do? You take the first part of the first term. Sorry, first term of the first part. This is the first part here. We are taking the first term, which is 1. Okay. 1 has to be multiplied with the x square term from the second part. Okay. So the second part is here. So here we are looking for the x square term, which is t3, the third term in the second part. So that will be 15c2 into minus 3 square into x square. So I'm looking for the coefficient of x square. So I will not write x square there. Next. The second term of the first part is ax. Okay, ax has to multiply with the x power 1 coefficient in the second part. Okay, second part, where is the x power 1 coefficient? It's 15a into, which is from the first part, into 15c1 into minus 3 power 1. Okay, this is where the x term is coming from. Next, here look at the third part here. Okay, third term of the first part is bx square. Okay, bx square has coefficient b and this multiplies with the constant term from the second part. The constant term from the second part is 15c0. Alright, so basically it's told to me that the coefficient of x square is 0. Okay, so from here I'll be getting my first equation, which is 15c2. I'll write that as 15 into 14 by 2 into minus 3 square, which is 9, plus a into 15c1 is 15 into minus 3. So this becomes minus here and this becomes 3 plus b equal to 0. 15 into 3, you already know, is 45. And this 2 and 14 cancel out to give 7. 15 into 63 becomes the first term now. Okay. 15 into 7 into 9, which is 63. Okay, we'll keep this as the first equation. Next, we'll be looking for coefficient of x cube. We know that it's 0, so we'll look for the coefficient of x cube now. So, for the coefficient of x cube, alright, I'll use a different color pen for this. For the coefficient of x cube, we have, again, two parts here. 1 plus ax plus bx square and 15c0 plus 15c1 minus 3x plus 15c2 into minus 3x raised to 2 and so on. Okay, so coefficient of x cube, how do we find that? 1 has to be multiplied, 1 from the first part. Okay, 1 is multiplied with the x cube term from the second part. The x cube term from the second part is this one. Okay, 15c3 into minus 3 cubed. Okay, into x cube. X cube is the term here, but I'm looking for its coefficient. Alright, let's look at the next part. Next term of this part, first part, that is ax. So x has to be multiplied with the x square term of the second part. X square term of the second part is here, which is 15c2 into minus 3 square plus b into x square has to be multiplied with the x term from the second part, which is 15c1 into minus 3. And this whole thing comes to 0. That's what we already have here. Okay, so this becomes 15 C3 is 15 into 14 into 13 divided by 3 into 2 into 1. Okay, 15C3 into minus 3 cube. So I'll write that as 3 cube into minus 1. Okay, plus A into, what's 15C2? 15 into 14 divided by 2 into 3 cube. Minus 3 cube is same as 3 square. Minus 3 square and 3 square have the same value. Okay, plus b into 15c1 is 15 into minus 3. 15 into minus 3 is minus 45. Okay, I have this much with me. So here, I'll try cancelling a few terms out. 3 square goes, 4 and 7 goes. Now, here, in the next part, 2 and 14 goes to give 7. And now there is no denominator. Now, in all these terms, I notice there's a 15 and 3 common. So, I'll divide by 45 throughout. Okay. So, it becomes, this equation becomes, 15 goes off, 3 also goes off. So, 7 into 13 into 3. So, 7 into 3 is 21. Okay. This is what I get from the first part. Now, the second part, I remove 15 and 3. Don't forget. Okay. Into 15. No, 15 is not there because I'm removing 15. I'm removing a 3 as well. Okay. So 15 goes and 3 square goes and becomes 3 power 1. Alright. So 15 goes, 3 power 1 remains, 7 remains, and that's it. Minus b into, I removed 15 and 3. That's why 45 will also go here. Okay. This is my second equation. Okay. So this can be written as 21a minus b. Alright. Okay, so these are the two equations I get. Alright, I notice that. Okay, so I'll just multiply this equation by minus 1. What will happen? The coefficient of b remains the same. Okay, so these two equations I got right now. Okay, so here I notice that the coefficient of b is the same. Alright, so what will I do here? I'll simply subtract both these equations, remove b, I am left with a linear in a. I'll just simply solve for a. So when I subtract both, what happens here? So there's 15 into 63 minus 21 into 13 minus 45 plus 21. Okay, minus 45. So that plus 21, write it as minus 21 itself into a. Then plus b minus b cancels out and this whole thing still comes out to 0. Okay, so how can I find a here? I can, 45 minus 21 is 24. Minus 24, when I take it to the RHS, becomes 24a. What am I left with here? I am left with 15 into 63. I'll write that as 3 into 5 into 7 into 9. Okay, that's 63. Minus 21 into 13. So 31 into 3 into 7. I notice that 3 into 7, or in other words 21, is common for both. And I'm left with 5 into 9, which is 45 minus 13. So this becomes 21 into 32, which is 24a. I'll write that as 3 into 8a. Now 8 and 32 cancels out, I get 4 here. 3 and 21 cancel out, I get 7. So a becomes 28 here. Alright, got that. So now that we got a, how can I find b? Substitute into any one of these two equations. Okay, to find b, I'll write b as 21a minus 21 into 13. So I'll write that as 21 into a minus 13, which becomes 21 into 28 minus 13, which is 15. Now what's 21 into 15? So 21 into 10 is 210. 21 into 5 is 105. You add both of them up, you get 21 into 15, which is nothing but 315. So the value of A comma B will be 28 comma 315. Alright, so now let's look at our options. We see that it's nothing but option D here. A is 28, B is 315. Got that?